Second question. Show that any positive add integer is of the form 6q plus 1 or 6q plus 3, 6q plus 5, where q is some integer. Now, first of all, Euclid's division algorithm. Euclid's division algorithm. Euclid's division algorithm is A is equal to BQ plus R, and 0 is less than or equal to R is less than B. Now solution. Let A be any positive odd integer. Let A be any positive odd integer. Let A be any odd positive integer and B is equal to 6. Now applying Euclid's division algorithm. Euclid's division algorithm. To A and B. Let A be any positive odd integer, B is equal to 6, and apply Euclid's division algorithm to A and B is equal to 6. Now A is equal to 6q plus R. R is bounding between 0 is less than or equal to R is less than 6. A is equal to 6q plus R. 0 is less than or equal to R is less than 6. R వాల్యూ ఎప్పుడు కూడా 0 కన్నా ఎక్కువగా కానీ లేదా ఈక్వల్ గా కానీ అలానే డివైజర్ కన్నా తక్కువగా ఉంటుంది. R వాల్యూ ఎప్పుడు 0 కి ఎక్కువగా కానీ లేదా ఈక్వల్ గా అలానే డివైజర్ కన్నా తక్కువగా ఉంటుంది. ఫర్ ఎగ్జాంపుల్ 8 ని మనం 2 తో డివిజన్ చేస్తే 2 4s are 8. ఇక్కడ రిమైండర్ ఎంత వస్తుంది? 0 వస్తుంది. రిమైండర్ ఇస్ ఈక్వల్ టు 0. ఇక్కడ రిమైండర్ వాల్యూ ఎలా ఉంది? మనకి 0 కి ఈక్వల్ గా ఉంది. లేదా 9 ని 2 తో డివిజన్ చేస్తే 2 4s are 8. 1 మిగులుతుంది. ఇక్కడ రిమైండర్ వాల్యూ ఎలా ఉంది? 1 ఉంది. అంటే 0 కన్నా ఎక్కువగా ఉంది లేదా డివైజర్ కన్నా తక్కువగా ఉంటుంది. సో ఆర్ వాల్యూ ఎప్పుడు కూడా 0 కి ఎక్కువగా లేదా ఈక్వల్ గా అలానే డివైజర్ కన్నా తక్కువగా బౌండ్ అయి ఉంటుంది. నౌ A is equal to 6q plus R. ఇప్పుడు ఆర్ వాల్యూ ఎక్కడ బౌండ్ అవుతుంది? మనకి 0 కి 6 కి మధ్యలో బౌండ్ అవుతుంది. అంటే R is equal to 0 1 2 3 4 5. ఆర్ వాల్యూ ఎక్కడ వరకు తీసుకుంటాం? మనం 0 నుంచి 5 వరకు తీసుకుంటాం. డివైజర్ కన్నా తక్కువ ఉంటుంది కాబట్టి డివైజర్ ఇక్కడ 6 కన్నా తక్కువగా తీసుకుంటాం. అంటే 0 నుంచి 5 వరకు ఆర్ వాల్యూ తీసుకుంటాం. ఇప్పుడు A is equal, if R is equal to 0, if R is equal to 0, A is equal to 6q. If R is equal to 1, A is equal to 6q plus 1. If R is equal to 2, A is equal to 6q plus 2. If R is equal to 3, A is equal to 6q plus 3. If R is equal to 4, A is equal to 6q plus 4. If R is equal to 5, A is equal to 6q plus 5. బట్ మనం ఏం తీసుకున్నాము? ఏ వాల్యూ ఎలా ఉంటుందని చెప్తున్నాము? లెట్ ఏ బి ఎనీ ఆడ్ పాజిటివ్ ఇంటీజర్ అని చెప్పాము. ఏని మనం ఆడ్ పాజిటివ్ ఇంటీజర్ అని చెప్తున్నాం. ఇక్కడ ఆడ్ పాజిటివ్ ఇంటీజర్ అని తీసుకుంటున్నాం కాబట్టి ఏని ఇక్కడ మనకి ఏ అనేది 6q అవ్వదు. తర్వాత అలానే 6q plus 2, 6q plus 4 లో ఏ వాల్యూ అనేది ఉండదు. ఎందుకని? ఏని మనము ఆడ్ పాజిటివ్ ఇంటీజర్ గా తీసుకుంటున్నాం. ఏని ఆడ్ పాజిటివ్ ఇంటీజర్ గా తీసుకుంటున్నాం కాబట్టి ఏ కెనాట్ బి రిటర్న్ ఇన్ ద ఫార్మ్ ఆఫ్ 6q plus 2 and 6q plus 4. So A is equal to, we can write as A is equal to 6q plus 1, 6q plus 3, 6q plus 5. Therefore, any odd positive integer is in the form of 6q plus 1, 6q plus 3, 6q plus 5. Use Euclid's division lemma to show that square of any positive integer is of the form 3p plus 1. Use Euclid's division lemma to show that the square of any positive integer is of the form 3p and 3p plus 1. Solution. Let A be any positive integer. Let A be any positive integer. positive integer and b is equal to 3. By applying Euclid's division algorithm, by applying Euclid's division algorithm to a and 3, by applying Euclid's division algorithm to a and 3, then a is equal to 3q plus r, where r is 0 is less than or equal to r is less than 3. Now consider r is equal to 0, 1, 2. If r is equal to 0, a is equal to 3q. If r is equal to 1, a is equal to 3q plus 1. If r is equal to 2, a is equal to 3q plus 2. By squaring on both sides, a square is equal to 9q square. Here a square is equal to 3q plus 1 whole square. Then a square is equal to 9q square plus 1 plus 6q. A square is equal to 3q plus 2 whole square. A square is equal to 9q square plus 4 plus 12q. Now a square is equal to 3 into 3q square. A square is equal to 3 into 3q square. Here a square is equal to 3 into 3q square plus 2 plus 1. Now a square is equal to 3 into 3q square plus 4q plus 1 plus 1. Here we consider 3q square is equal to p. Then a square is equal to 3 into p. P is equal to 3q square plus 2. Then a square is equal to 3p plus 1. P is equal to 3q square plus 4q plus 1. Then a square is equal to 3p plus 1. So, square of any positive integer is of the form 3p and 3. Square of any positive integer is of the form 3p and 3p plus 1. Therefore, square of any positive integer is of the form 3p plus 1. Division lemma to show that the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Cube of any positive integer is of the form 9m plus 1 or 9m plus 8. Solution. Let a be any positive integer. Any positive integer. And b is equal to 3. Now applying Euclid's division algorithm. Now applying Euclid's division algorithm to a and 3. Now applying Euclid's division algorithm to a and 3. A is equal to 3q plus r and r is bound in between 0 is less than or equal to r is less than 3. R value ఎప్పుడు కూడా 0 కన్నా ఈక్వల్ గా లేదా ఎక్కువగా and b కన్నా తక్కువ అంటే that means divisor కన్నా తక్కువగా ఉంటుంది. So we consider r is equal to 0, 1, 2. If r is equal to 0, a is equal to 3q. If r is equal to 1, a is equal to 3q plus 1. If r is equal to 2, a is equal to 3q plus 2. క్యూబ్ ఆఫ్ ఎనీ పాజిటివ్ ఇంటీజర్ అన్నాడు. సో ఏ అనేది మనం పాజిటివ్ ఇంటీజర్ అనుకుంటున్నాము. క్వశ్చన్ మనకి క్యూబ్ ఆఫ్ ఎనీ పాజిటివ్ ఇంటీజర్ అన్నాడు. సో క్యూబింగ్ ఆన్ బోత్ సైడ్స్, క్యూబింగ్ ఆన్ బోత్ సైడ్స్, cubing on both sides. A cube is equal to 3q whole cube. A cube is equal to 3q plus 1 whole cube. A cube is equal to 3q plus 2 whole cube. రెండు వైపులా if r is equal to 0, a is equal to 3q. If r is equal to 1, a is equal to 3q plus 1. If r is equal to 2, a is equal to 3q plus 2. Cubing on both sides. That means a cube is equal to 3q whole cube and a cube is equal to 3q plus 1 whole cube and a cube is equal to 3q plus 2 whole cube. Show that one and only one out of n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. Show that one and only one out of n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. Where n is any positive integer. Solution. Let n be any positive integer. Let n be any positive integer. Let n be any positive integer. Then b is equal to 3. By Euclid's division algorithm. By Euclid's division algorithm. Let n be any positive integer and b is equal to 3. By Euclid's division algorithm, n is equal to 3q plus r, where r is bounding 0 is less than or equal to r is less than 3. Now n is equal to 3q, where r is equal to 0. By Euclid's division algorithm, n is equal to 3q plus r. 0 is less than or equal to r is less than 3. Now if r is equal to 0, n is equal to 3q and n plus 2 is equal to 3q plus 2 and n plus 4 is equal to 3q plus 4. Here n is equal to 3q is divisible by 3 since the remainder is 0. Here n is equal to 3q which is divisible by 3. Here r is equal to 0. Remainder is equal to 0. So n is equal to 3q is divisible by 3 and n plus 2 is equal to 3q plus 2 is not divisible by 3. Is not divisible by 3 since the remainder is equal to 2 and n plus 4 is equal to 3q plus 4 not divisible by 3 since the remainder is 4. Remainder is equal to 4. Let n be any positive integer and b is equal to 3. By Euclid's division algorithm, n is equal to 3q plus r and where 0 is less than or equal to r is less than 3. So if r is equal to 0, n is equal to 3q. Then n plus 2 is equal to 3q plus 2 and n plus 4 is equal to 3q plus 4. Here n is equal to 3q. Since the remainder is 0, it is divisible by 3. n plus 2 is equal to 3q plus 2. Here remainder is 2. So it is not divisible by 3. Here n plus 4 is equal to 3q plus 4. Here remainder is 4. So it is not divisible by 3. Next case 2. If r is equal to 1, n is equal to 3q plus 1. If r is equal to 1, n is equal to 3q plus 1 and n plus 2 is equal to 3q plus 1 plus 2, that is equal to 3q plus 3 and n plus 4 is equal to 3q plus 1 plus 4, that is equal to 3 cube plus 5. If r is equal to 1, n is equal to 3 cube plus 1, n plus 2 is equal to 3 cube plus 1 plus 2, that is equal to 3 of cube plus 1. If r is equal to 1, if r is equal to 1, n plus 2 is equal to 3 cube plus 1 plus 2, that is equal to 3 cube plus 3. So 3 of cube plus 1 is divisible by 3. Since the remainder is remainder is 0. Here, if r is equal to 1, n is equal to 3 cube plus 1 is not divisible. Is not divisible by 3. Since remainder is not equal to 0. Since the remainder is not equal to 0, if r is equal to 1, n is equal to 3 cube plus 1 and is not divisible by 3. Since the remainder is not equal to 0. If r is equal to 1, n plus 2 is equal to 3 cube plus 1 plus 2. So 3 of cube plus 1. Here remainder is 0, so it is divisible by 3. And if r is equal to 1, n plus 4 is equal to 3 cube plus 1 plus 4. That is equal to 3 cube plus 5. Is not divisible by 3. Since remainder is not equal to 0. Remainder is not equal to 0. Next, case 3. If r is equal to 2, n is equal to 3 cube plus 2. If r is equal to 2, n is equal to 3 cube plus 2. If r is equal to 2, n plus 2 is equal to 3 cube plus 2 plus 2. That is equal to 3 cube plus 4. And n plus 4 is equal to 3 cube plus 2 plus 4 is equal to 3 cube plus 6. That is equal to 3 half cube plus 2. If r is equal to 2, n is equal to 3 cube plus 2. If r is equal to 2, n plus 2 is equal to 3 cube plus 2 plus 2. That is equal to 3 cube plus 4. If r is equal to 2, n plus 4 is equal to 3 cube plus 2 plus 4. That is equal to 3 cube plus 6. So 3 of cube plus 2. 3 of cube plus 2. Here n is equal to 3 cube plus 2 is not divisible. Is not divisible by 3. Since remainder is not equal to 0. N plus 2 is equal to 3 cube plus 4 is not divisible. Is not divisible by 3. Since remainder is not equal to 0. Remainder is not equal to 0. If r is equal to 2, n plus 4 is equal to 3 of q plus 2. That is equal to 3 of q plus 2 is divisible. Is divisible by 3. Since remainder is equal to 0. If r is equal to 2, n is equal to 3 q plus 2 and is not divisible by 3 since the remainder is not equal to 0. If r is equal to 2, n plus 2 is equal to 3 q plus 4 is not divisible by 3 since remainder is not equal to 0. If r is equal to 2, n plus 4 is equal to 3 q plus 6 that is equal to 3 of q plus 2 is divisible by 3. Here remainder is 0. In 3 cases, if r is equal to 0, n is equal to 3 cube is divisible by 3. If r is equal to 0, n is equal to 3 cube is divisible by 3. If r is equal to 1, n plus 2 is divisible 1, n plus 2 is divisible by 3. If r is equal to 2, n plus 4 is divisible by 3. If r is equal to 0, n is divisible by 3. If r is equal to 1, n plus 2 is divisible by 3. If r